Hello, math enthusiasts. We're going to be continuing on today in this video with question number 5 for the 2014 CIMC paper. So let's take a look at question number 5. Alright, Scott stacks golf balls to make a pyramid. The first layer, or base of the pyramid, is a square of golf balls and rests on a flat table. Each golf ball above the first layer rests in a pocket formed by 4 golf balls in the layer below, as shown in figure 1. Here we go. Each layer, including the first layer, is completely filled. For example, golf balls can be stacked into a pyramid with 3 levels, as shown with figure 2. The 4 triangular faces of the pyramid in figure 2 include a total of exactly 13 different golf balls. Scott makes a pyramid in which the 4 triangular faces include a total of exactly 145 different golf balls. How many different layers does this pyramid have? So basically the question's saying this is the number of golf balls appearing on the outside of a pyramid. How high has his square-based golf ball pyramid been built? Okay. So it might be a good idea for us to try and say, suppose we had a pyramid of height and how many faces are there on the outside. Okay, and then if we could get a formula in terms of n, we could set that equal to 145 and just reverse and solve for whatever n is. So let's take a look at the pyramids and the outsides of the pyramid. So we have a little something like this. 1, 2, 3. And we have more golf balls at the back. That's the idea. So in order to count the total number of golf balls on the outside, so in those 4 triangular parts, what we can do is we can look at it layer by layer. So as an example of what I'm talking about, let's look at the height 3 pyramid and try and count the number of golf balls on the outside of it. Okay, and we'll go layer by layer. We'll start with the top layer and we'll work our way down. And if our method of counting gets us 13, then we're likely on the right track. So the first layer, if we were to sort of do a top-down view, we'd get just 1 golf ball. 1 golf ball right there at the top. He's part of the triangular faces. In fact, he's part of all of the triangular faces. So he's definitely counted, but we only count him once. So what does the second layer look like? Well, it looks like this. There's 4 balls in the second layer, and as we can see, they're all part of the outside. Now the third layer is where something different's going to happen. The third layer is made up of a 3x3 arrangement of the golf balls. But the one in the absolute middle, he's not part of the outside. So we don't count him. And if we see 1 plus 4 plus 8 is 13. So we're definitely counting right. So how about the fourth layer? You know, suppose we had a 4-layer one. How many golf balls would we have on the outside? Well, we'd have a 4x4 grid. But once again, some of the golf balls not on the outside faces. In fact, we get 12 balls here. Okay, so excluding that first layer where there's really not a lot to talk about, we get 4, we get 8, we get 12. If we were to do the fifth one, I don't even need to fill those in. We could count and we'd get 16 balls. So for n layers, we could guess at the formula. 1 plus 4 plus 8 plus 12 plus all the way up to, so for 2 layers we had 4, for 3 layers we had 8, for 5 layers we had 16. You can abstract a pattern right there. So we go 1 plus, and then 4, 8, 12, all the way up to 4 times n minus 1. Now we can rearrange this formula. We get 1 plus, then we take out 4s, and we get 1 plus 2, all the way up to n minus 1. But there's a formula for this. It's the sum of the first n minus 1 numbers. There's a formula here. So if you wanted the sum of the first k numbers, you would do k times k plus 1 over 2. So our formula becomes n minus 1 times n minus 1 plus 1 over 2. And we can cancel this guy and this guy. So 1 plus, a little 2 left over there, 2 times n minus 1, n. Okay. Now we want to know what happens if we have 145 golf balls exactly on the outside. Well, we set it into this formula right here. Okay. So moving the 1 over to the other side, we get 144 is equal to 2 times n minus 1n. And if we divide that by 2, we get 72 equals n minus 1n. So if you wanted to, you could go looking for an integer n where n times n minus 1 was equal to 72, and you might be able to see it right off the bat, but if you didn't, that's okay. We can do a sort of quadratic formula sort of thing. N squared minus n minus 72 equals 0. N equals negative b plus or minus square root of b squared minus 4ac. All over 2. And we get 1 plus or minus square root of 289, which is 17 squared, over 2. So 1 plus or minus 17 over 2. We need n to be positive, so we're going to take the positive one. So 1 plus 17 over 2. That's going to quickly be 9. So how many layers are there that give us 145 golf balls on the outside? 9 layers. Okay. And we could have seen that up here. We could have just guessed 9 times 8, that's 72. That's one of the things you should know. You should be able to tell me what numbers multiply to be 72. So you can say 6 and 12, 9 and 8, things like that. They're just sort of things that should eventually come to you as you work with these numbers often enough. You can start prime factorizing them in your head. But if you're unsure of your arithmetic and you don't want to play around in your calculator, surefire way to get things done. Quadratic equation, quadratic formula, and of course n's going to have to be positive, so that's why we can throw out this minus sign at the end. Okay? We'll make a little note. So we can just make our little note that n must be positive. And we get 9 layers, and we just double check. How many layers does the pyramid have? Exactly 9. A place where we might trip up with this question is we might mislabel our formula when we apply 145 to it, and we might accidentally list 8 as the number of layers. That'd be something worth checking. And so if you just put 8, that's the wrong answer, so you'd lose all your marks. But if you show your work, as we have, if you show your derivation of the formula, and you just happen to misapply it, you'd lose maybe 1 mark. And so that's why showing your work, even in these Part A questions, is still valuable. Okay? You just don't want to be dwelling and have nice, clean, clear, agonizing over all your solutions in Part A, but you do want to be able to get part marks if you were to screw up. So that concludes question number 5, and in the next video we're going to move on to question number 6, which is the last of the Part A questions. So hope you've been enjoying these questions in the 2014 paper so far, and I'll see you guys for question number 6 next time.